All right, our title today says finding the dimensions of a given area. I want you to put a box around the word dimensions. Put a box around the word dimensions. When you see the word dimensions, what are we thinking about? Marley, what are we thinking about with dimensions? We should be thinking about length and width. But when there's more dimensions than that though, right?
Length, width, and height.
Yeah, there are more dimensions, but in third grade land, in our area work, we're only working with length and width. Yep. You'll be working with more dimensions as you get to 4th and 5th grade, but just in 3rd grade, we're going to be working with length and width. Now, the end of this sentence kind of sounds funny. It says, of a given area. Go ahead and just underline that.
It does make sense.
That's kind of an interesting way.
Of the area that they give you.
Yeah, it's literally what that means. A given area means I am telling you
The exact area.
the area. That's what that means. So a given area just means I've already given it to you. I'm saying the area is this. That sentence just made me feel
And you're trying to find
weird
the
to
length
read.
and width. Instead of finding
So we practiced this a couple days ago with some graph paper, and we looked at some strategies to do that, some patterns that we noticed. If I say the area of my shape is worth 10 square units, what could my dimensions be? How am I going to solve that? Now, in 3rd grade, your shape is always going to be a rectangle or a square. So let's go ahead and draw a rectangle.
not like a rhombus.
No. You can find the area of a rhombus, we're just not going to in 3rd grade.
Because rhombuses are complicated.
Yeah, they have like pieces. Just like when our sticky notes came off our desks.
Yeah.
Same thing happens when you try to find the area of a weird shape like that. Doesn't matter. I know that the area of this is 10 square units. I already know that. Yep, we already know that. Just told us that. What I don't know is I don't know my length and I don't know my width.
Oh, sleep, makeup.
What could I do now? Well, what are you thinking? What could I do now?
You could just try a whole bunch of different lengths and we'll see which one works.
Absolutely. We could just try some and then go from there. If we get a number that's too big, we know, okay, we need to try something smaller. If we get a number too small, we can increase it. Bowen, do you have some ideas of what numbers you would like to try?
5 by 5.
A 5 by 5. All right, so if I have a 5 by 5, I have 5 rows with 5 in it. What equation is that going to be? 5 rows with 5 in it.
5 times.
Snubby? Yep. Get your fingers going. What is that worth? Callie, what's that worth? 25. Wait, is that 10? No. It's too big. So we're going to need to lower one of our dimensions. my next guess should not be a 10 by 10 because I already know a 5 by 5 is not going to work. A 10 by 10 is absolutely not going to work. That was a really good start, though. Ava, where do you want to try now?
You can turn one of the 5s into a 2.
Okay, so you want to try a 5 by 2?
Yep.
All right, so I'm going to erase this 5. You can cross it out if you want. And now I'm going to try a 5 by 2. So now, all right, I've got 2 rows of 5. What equation is that going to be?
5 times 2.
Sure. 2 times 5, or I could say 5 times 2, because I am not actually building anything.
We have to write 2 times.
They're going to be worth the same for our commutative property. What is 5 groups of 2 or 2 groups of 5 going to be worth? Connor, playing in your desk does not show me that you're paying attention. Jordan, what you got?
Okay.
10. Hey! Did that work?
Yeah!
So my dimensions could be 5 units by 2 units. Are there any other options? Because remember, think back to when we did the graph paper with 36. There were so many possibilities. Can you think of another option that would work? Avery?
One group of 10.
Oh. So this is not going to match my picture, but could I do a 1 by 10?
Yeah, still equals 10. Because anything times 1. Can we make that a rectangle?
Yes. This shape is not a good representation of what that actually looks like. You know, or it's up spinning around. You know that a 1 by 10 is going to be really skinny and really long. But once again, I've got a 1 group of 10, which is going to give me my area of 10 square units. Avery?
Can't the shape, can't you kind of like it's the same shape, but can't you like move it around to make it like that? And it could still be 10, still have the same value?
Are you talking about like turn it?
Yeah.
Yeah, my dimensions aren't going to change. But yes, I could draw my 1 by 10 sideways, like lengthwise or vertical. But my dimensions are still going to be a 1 by 10 or 1 by 1.
When you have a 1 times 10, circle, you don't add an extra group. It would still be the same number because you have one group of that number.
Yep. Go on.
What was it going to say? Oh, 3 by 4.
You want to try 3 by 4? Do you think it's going to be 10? All right, so if I get a 3 by 4, what equation is going to go with that?
4 times 3.
Yep, we're trying it out. So let's try 4 by 3. Sloan, are you good at 3s or 4s?
I'm good at 4.
You're good at 4s, so you could do 4 3 times. Go for it. 4. What's next? 8.
12.
If you want to be really fancy, check this out. So we found out that a 2 by 5, oh, I just moved my elbow, sorry, worked, and a 1 by 10 worked. Do you see any relationship there?
Oh! It's doubling.
Doubling and
Subtracting.
what's happening here?
Subtracting.
Because 5 to 10 is doubling, that I get. But what's happening 2 to 1?
It's half of the number.
Yeah, so what's happening is I can figure it out by doubling one side and then halving the other side.
That's cool.
Isn't that neat? So let's think back to when we did our 36. Remember when we did our 36? You do not need to write any of this. I just want to show you something cool that you can do with numbers. So we had a 1 by 36. Let's double my 1. What's double of 1?
2.
And then let's half my 36.
25. 12. So we're doing 28. 13.
Very close.
29.
18.
Oh,
Double your 2.
4.
4. Half your 18.
6. 9. Oh yeah.
Were all of those equal to 36?
Yeah.
Isn't that cool?
Yeah.
You could keep going. What's double of 4?
8. Double 6. I was thinking of
Now this is going to be really tricky. What's half of 9?
It's 5.
It's not 5.
It's 4. 4.5. Let's go. 4.5. I knew that. Decimal. We're so.
Guess what this is equal to?
36. Can we keep going?
You could keep going. It will always. So what's happening is I'm punching. What's happening is if I were to see this on a number line, all I'm doing is taking the same distance and just moving it. So I'm taking the same amount of stuff, I'm just
Almost
moving it. Does that make sense? Kind of? Alright, this was just something interesting that I wanted to show you that you can do. So we're going to get started on our task.